Hi guys, so in this video I want to talk about elimination reactions and how one pathway is different from another pathway. So why we need to study about elimination reaction? So this is the main area that I was struggling. So when you have a same starting material and when you end up with the same product, but there are two different kind of elimination reactions, how you find out which mechanism undergoes by which pathway. So I will describe, since this was a challenge for me, I found out a way how to find out the mechanisms and how we study the kinetics. So I will describe how to do that. For that, I use several textbook and I got some ideas from my colleagues. So these are the things I wrap up from their ideas and the factors I got from books. So first of all, we have to study about the nature of the reaction conditions, because whenever the reaction conditions differs, the elimination pathway differs. And then we have to study about the nature of different starting materials, because some of the starting materials need a special kind of functional groups and some don't. Then we have to figure out their reaction pathway, whether it's a two-step or one-step reaction. Then finally we have to determine their rate determining step, because rate determining step is the main factor which determines the rate. So in the previous example I showed you two different kind of mechanisms, E1 and E2 mechanism. So I will describe the same reaction as the example and how you can differentiate these mechanisms. First of all, I would like to give you a brief introduction about E2 elimination, and before that, elimination is a process in which one molecule is split into two or more molecules. So here you can see we have two different kind of elimination reactions. First of all, E2 elimination I will describe. So in the E2 elimination, you need to have a good strong base. So remember, as the reaction conditions, we mentioned that we have to study about the nature of bases. So here, remember, we have to have a strong base. Then we need to study about the starting material. Here you have to have a good leaving group. Strong base and good leaving group will lead to E2 elimination. And then what about the reaction pathway? This is a one-step reaction. So I will describe how this can be a one-step reaction. Since this is a one-step reaction, there are no intermediates formed. So okay, let's look at the example. So here I have put the same alkyl bromide but with a strong base. So and it is giving the corresponding product. So here you can see, since we have used the strong base, the strong base first of all deprotonate this proton, and therefore this bond will cleave, forming a 5 bond in between these two carbon, and therefore this carbon bromide bond will be broken. So you can see, as a result of this we get this alkene. So since there are only one step, so this is the only step which determines the rate. So you can see in the rate determining rate, there are two types of species in the rate equation. So these are the two species. So you can see both this strong base and the starting material affect to the rate. So when it comes to the E1 elimination, not like E2 elimination, here we don't need a strong base, but we do require a good leaving group. So this is not like E2 elimination. Remember, E2 elimination is a one-step reaction, but here this is a two-step reaction. So how do you know this is a two-step reaction? So here I have mentioned the same alkyl bromide but different base. So the basicity of water is less than sodium methoxide. So you can see, since we haven't used a strong base, the deprotonation will not take place as first. So what happened is, here we have used a good leaving group. So what happened is, first this carbon bromide bond will be broken, and then as a result of this carbocation will form. Then this base will deprotonate this proton, and therefore we'll get the corresponding alkene. So the other important thing is, in the E1 elimination is, even though in this reaction we got the corresponding alkene, in some cases because of the carbocation formation we get rearrangement. So carbocation rearrange. So let's say the carbocation formed here. So if the carbocation formed here, it's a primary carbocation, right? So primary carbocations are not that stable. In order to be stable, it will rearrange and form a more stable carbocation. So in E1 elimination mechanism, we can get rearrange product. So there's another possibility. So now you know the difference between the E1 and E2 mechanism. Even though we end up with the same alkene, due to their differences in the mechanism, the rate will be different. So in the previous case, it was a second order reaction, but in this case this is only first order reaction. How we know that this is a first order reaction? See, the rate determining step of this E1 elimination pathway is the first pathway. That means the formation of carbocation. So for the formation of carbocation, only the starting material is involving. So in the rate equation, only the starting material should be appear. So these are the main differences in between E2 and E1 elimination. So I hope now you can differentiate the E1 and E2 elimination. So this is the end of my short video. Thank you very much.